To solve proportional problems, we can just find a multiplier or divisor to get us from one fraction to another. So for example, I've got a multiplier of times by 0.4 to get from bottom to top, so I can go in this direction and divide by 0.4 to get x. So when I do that, I get 7 divided by 0.4. And that gives me 17.5, so x is equal to 17.5. Okay, so that's one way we can solve this proportional equation. Now, some people like to use cross multiplication. So if you know exactly how it works, we can multiply like that. Oops. Okay, 5 times 7 is going to give us 35. Divide both sides as an equation by 2, and we get 17.5 that way as well. So the same way, two different ways of getting the same thing. Now here I can use, again, I'm going to use my multiplier. I've got times by 0.23. That multiplies my unit rate, and I can then just use that unit rate and times by 0.23, and that gives me my x as well. Okay, so I end up with 0.15 times 0.23, and that gives me 3.45. Okay, so this is technically not a fraction because fractions are a ratio of whole numbers, but the proportions work exactly the same. We just may get some decimal answers here. And again, if we chose a different strategy, as long as we have a concise strategy that works and we understand the math that's going on, that's perfectly fine. Here, this proportional equation represents a map scale. So on a map, I've got 0 to 5 centimeters. And on that same map, that represents 0 kilometers to 23 kilometers. Okay, so when I have these parallel number lines, these are representing proportions. Okay, so I want to find out how many centimeters apart are the two cities that are 15 kilometers apart. So I can write this as centimeters to kilometers comparison, or I can do centimeters to centimeters, kilometers to kilometers. I'm going to do this. I'm going to do 5 centimeters on the map compares to 23 kilometers in real life. And we can write this as long as we have the proportion the same. In this case, I get 15 kilometers on bottom, and the top is what I'm looking for. Okay, so if I want to find the top, I can find my unit rate. So I can divide 5 by 23. And my multiplier, just going to zoom in here, it's not a very nice number. It's times by 0. It looks like 2173. So I'm just going to round that to 217. And I'm going to use that exact same multiplier times by 0.217. And that gives me an x value of 3.26. 260, so I'm going to round that to 3.26. And that's going to represent centimeters. Okay, so my unit rate is going to be the unit rate is 0.217, and that's centimeters per kilometer. And we can have a reciprocal unit rate, and that would be, if I were to use a reciprocal unit rate, that's going to be 4.6 kilometers per centimeter. And that's actually a much nicer unit rate. So I'm going to write this as 4.6 kilometers per centimeter. Now, we could also do this using a multiplying strategy. I'm starting with 15 kilometers, and I want to end up with centimeters, and I need to get rid of the kilometers with a multiplier. So times, well, if I want to get rid of, my ratio is 23 kilometers to 5 centimeters. Now, if I want to get rid of kilometers, I want to cancel these out. That needs to be in the denominator, and the 5 centimeters needs to be in the numerator. And if I do times on top, divide on bottom, I go 15 times 5, divide by 23. That's going to give me the exact same answer of 3.26. Okay, so that's going to equal 3.26. Now, this again is a different strategy. This is a multiplying strategy, and it's called unit analysis. For D, Jason buys a pair of jeans at 15% off, and he pays 12% tax. The total that he paid was $65.64. How much was the original price? Well, in this case here, we don't know what the original price is, so we're going to call that X. And to get to that original price, we're going to get 15% off. Now, we always multiply by what we have. So if I get 15% off, I pay 85%. And then I have to pay 12% tax. Well, I have to pay the original 100% plus an additional 12%. So I can just multiply by, instead of adding 12%, I could just multiply by 1.12. And that gives me to the answer of $65.64. Now, unfortunately, I don't want the calculation. I want to undo this calculation. Well, I know how to undo, and I can undo by using opposites. So I'm going to just rewrite this. So that's times and times. I can undo times with divide. Now, because this is an equation, I just have to remember I have to make sure that I balance. So if I get rid of the 0.85 with a divide, I just have to make sure I divide by 0.85 on the other side. There it is. If I undo the 1.12, by divide, I need to balance by dividing by 1.12. And so now on the left-hand side, I've got the starting amount. Okay, that is my original price. I'm just going to highlight that. The original price is X. Okay, and I can just calculate then 65.64 divided by 0.85 divided by 1.12. I'm going to end up with $68. The original price was $68 and 94.9, so I'm going to round that to 95 cents. Okay, so that represents my original price, so that's my answer. That's my original price here.